Hello dear student, you are welcome to my video lecture, and myself Professor Ashok Kumar. I am working at Department of Mechanical Engineering in Dr. Subhash Technical Campus. Today we are going to discuss chapter number 4, Special Mechanisms, and this is consecutive second part on same chapter, through which we will discuss the remaining portion of this chapter. As you might have attended my previous video lecture on same chapter, special mechanism, we have discussed a few special mechanism like pantograph, ratchet and escapement mechanism. Then we are also discussing on an indexing mechanism. Then after we have also discussed on swinging on, or we can say that the rocking mechanism. And at the end we have discussed on specially equivalent linkage of the mechanism, in which we have specially we can say that we have specially convert the pair like sliding and other types into turning pair, so that the identification of velocity and acceleration of each and every link can be very easy to calculate. So this was the few special mechanism which are being widely used for the special function or the special requirement. Basically, we know that the special mechanism we are using for this special purpose, and this is the reason why such type of mechanism find its very special application. So basically such type of mechanism is made in we can say that our conventional mechanism by modifying little bit any part or link or joint. In that way we can have the special mechanism. Let's start the remaining type of the special mechanism and look at the screen. That is, P-cellular mechanism comes first in exact straight line generating mechanisms category. You can see that from the diagram. You can see that the configuration of P-cellular mechanism. As look at the screen, you will easily understand the basic mechanism and assembly of linkage in P-cellular mechanism. It is basically an exact straight line generating mechanism, and if we are talking about the relative dimension of the various links, then it will become like capital AC that is equal to CB, that is equal to BD, and that is equal to DA. Now we also conclude that whatever the length of link OC is always equal to the length of OD. So this is some geometrical configuration of various links in P-cellular mechanism. Now if you are rotating a link O1A like this link, you are rotating about fixed point O. It can be provided that product of OA link and OB is constant as O1A rotate. That means if you are rotating this link and considering it link as a crank, and you are rotating in any direction, whatever the link dimension, that is OA and OB, that means this dimension OA and OB, the product of that dimensions will remain constant whether in which direction you are rotating link O1 and A. So it will not change anyway, but product is not the change with respect to rotation of say link O1A. Now for the analysis, kindly consider triangles ORC and BRC. That means you have to consider triangle O, R and C, and of course you have to also consider the triangle BRC, that means B, R and C. And by using the geometric relation, you can write like OC square is equal to OR square plus RC square. It is basically a Pythagoras theorem. And similarly, you can have the relation from the triangle BRC, that is BC square is equal to RB square plus RC square. Now you can easily convert this both of the equation in a third equation by putting the values of we can say that subtracting the equation of both of equation with each other, you are getting that just you have to subtract the equation of BC square from equation OC square. So ultimately you are getting like OC square minus BC square, and that will be equal to OR square minus RB square, because we know that this is the common term. So when you are subtracting it will be cancelled out. And specifically this equation can be written like x square minus y square. In that manner you are getting that OR plus RB and OR minus RB. So ultimately if you are looking specially for OR plus RB in the p-cellular mechanism, then you can see that OR and plus RB. So ultimately it will becomes the entire link. So we can say that this summation of link OR and RB can be easily replaced by putting the values of link OB. Similarly, you can also replace the term terms. We can say that the OR minus RB. Suppose you are looking for the p-cellular mechanism again, and if you are subtracting the values of RB link, that means from the OR, ultimately you are getting that there is OA. Again I repeat how to replace. Actually OR, that means this is the entire length and this is OR, and you just require to subtract the values of link RB, that means this, but we know that RB is equal to AR. So ultimately you just have to subtract the values of this link AR from entire link OR. So by doing so you are getting that the remaining path, or we can say that the length of link will the OA. So we can say that OR minus RB is replaced by OA. Now as we know that, as I earlier said, the product of OA, OB and OA will remain same whether you are rotating this link O1A about the fixed point O1 in either direction. If you are rotating it in clockwise or anti-clockwise, it is immaterial. By doing rotation of that link, the product OB and OA will be always remain constant. So we can say that there is OC square minus BC square, that is equal to the product of OB into OA, and ultimately it will becomes constant. So ultimately we have here in short prove that the OC square minus BC square is of course the constant, and product of the dimension of link OA and OB are also remain constant during the rotational motion of link O1A. So in that condition, if you are rotating any link for the periodic time, we can say that the point B will remain constant and it moves along the straight line. So in that way you can generate the straight line profile of any machine component that you require to generate at the end. So this is what about the p-cellular mechanism, how it works and generate the straight line. After that the special mechanism of straight line generating mechanism is the Scott-Russell mechanism. It is very much important. Look at the diagram. This is the kind of exact straight line generating mechanism, and basically there are three movable links. From the figure you can say that the link OQ, of course this is the link OQ, then PS, this is the link PS. It is also can move in either direction, and of course the slider S can also move from right to left or left to right direction. So if we are talking about the dimension of such links, that means all three links, then we can say that the dimension of link OQ is equal to the link QS, and that is equal to the QS. That means over here the all that three dimension of link, that means OQ is always equal to PQ, and that is equal to QS. This is what about the geometric relationship between the each and every link. Now if you are rotating a link OQ, that means this link, you are giving a rotary motion, then the point P, that means this point, will move on straight line perpendicular to line QS. That means if you are giving little bit rotation to the link OQ, then whatever the point P which lies on the link PS will move in straight line direction, and it's the direction of moving will be always remain the perpendicular with respect to the link given to you, that means the link OS. So ultimately this is the link OS, and this sorry to say there is a little bit mistake for the understanding clearly. Let's repeat it. Exactly, first of all you have to rotate this link that you have given. If you are rotating in this link in any direction, either clockwise or anti-clockwise direction, basically this point P will move in upward or downward direction as per the rotation directional you have given to the crank OQ. So when you are rotating this link, this point P will move in upward or downward direction. So this is exactly becomes the perpendicular relation with respect to the link that you have given, and that link is OS. So over here point P maintains the perpendicular relation with respect to the link OS, and in that way the point P will generate the straight line that we required. So this is what about the Scott-Russell mechanism. Let's have the few mathematical analysis. Basically link OQ that is equal to OP QP, and that is equal to QS. So when a circle is drawn with PS as a diameter, that means kindly consider the PS, that means this, and you are drawing a circle like a PS, then the diameter will pass through the point O as well. Suppose you are taking the diameter PS and you are drawing a circle like that, so it will always pass through point P, or we can say that the fulcrum point O. Now the center of the circle will be the Q. Of course this will be the center of circle, and it will become the center of circle of Q for the diameter PS, and O point is a point on the circumference of the circle, and the angle subtended by the diameter, that is POS, and that will be the equal to 90 degree. That means if you are measure that angle POS, it will be always having the 90 degree angle. Now we have considered that any position of S, it will be true for all the position of S. If you are rotating link in any direction, slider will move in either direction or either direction, but it will maintain the constant perpendicular relation with the both of the sides. So it is here not depends that whether you are rotating crank in either direction, there will be always a perpendicular relation of the link S. Now it's clear means that the locus of point P will always lie on the straight line, because we know that the point P which generate the straight line in upward or downward direction must be maintain the perpendicular relation with respect to line of stroke, or we can say that the link OS. So we know that the link S especially will always having the perpendicular relation like that with respect to this axis. So ultimately for any kind of position of point P which is generating straight line, it will have the always perpendicular relation or 90 degree angle with respect to the line OS or link OS. So by performing this kind of actions, you are getting the straight line mechanism from this Scott-Russell mechanism. And of course there is one drawback of this system, and it is that it passed through the point O, which makes it very inconvenient. So in order to avoid the such type of condition, proportion of the links are made in such a way that the ratio of OQ upon QS should be always remain like the QS upon QP. That means whatever the dimension of OQ, that means this OQ, you are dividing it with the QS, should be always equal to the ratio of QS to that of the QP. If you are maintaining that ratio throughout, of course there will be no any kind of such type of we can say that the phenomena through which the circle pass through a fulcrum point O. So if you are doing so, the point P will move in a straight line mechanism, whether the circle having the very much less diameter or very large diameter. It's not depend on the particular straight line generating mechanism or Scott-Russell mechanism. It will always, a point P will always form a straight line if you are maintaining this proportional ratio. So this is what about the Scott-Russell mechanism that we have discussed. After that, there is very much important mechanism, a special mechanism, and that is Hart's mechanism. It is also a kind of exact straight line mechanism, and generally it has 6 links. You can see from the figure in Hart's mechanism have. And these links are AB, CD, AD, BC, OE, and OQ are the 6 links which are assembled in case of Hart's mechanism. Generally, the dimension of such links are such that the AB is always become equal to we can say that AD. That means this link AB and CD, that will be always equal to the AB is equal to CD, whereas we can say that AD is always equal to BC. Now if you are looking carefully diagram, the link OE is fixed links. So that means of course in any mechanism we require one fixed link. So over here link OE will work as the fixed link in this Hart's mechanism. Then the input rotary motion given to the link OQ, that means this is the link the O, and if you are giving input motion to this link OQ, the points E, Q and P are located by the dimension like AE upon AB is equal to AO upon AD, and that is equal to CP upon CB. So over here this is the prime condition of the ratio of dimensions of link should be maintained in such a way that the link dimension of link AE upon AB is equal to dimension of AQ upon AD, and that should be always equal to the dimension of link CP upon CB. Now just you have to consider triangles, and consider the triangle first ABD that we are going to discuss, and by considering that triangle you can have the relation of various link like capital AE, dimension of link AE upon AB, that will be always equal to the dimension of AQ upon AD. And similarly, if you are considering the triangle AEQ and ABD both, you can have the new relation for the dimensions of the link, and that will be the CP upon CB, and that is equal to AQ upon AD, and that will become finally the dimensions of link ratio like AE upon AB. So ultimately from this both of the relation, by taking various two similar triangles, you can write like the dimensions EQ upon BD, and that is equal to AE upon EB, and also EP upon SC, that is equal to the ratio of links BE upon BA. Ratio, just you have to draw radius OQ with a center O, and this OQ circle will intersect point link OA at Q dash. Now join QQ dash, that means Q and Q dash, just you require to join over here. And if you are joining, so you will have the new relation, and that is EQ upon EP dash, and that is equal to EQ dash upon EP. So by simplifying that relation, you are getting ultimately EQ dash into EP dash, and that is equal to EQ into EP. And of course we have already proved this relation in previous slide. EQ is equal to BD into AE upon AB. So finally, by solving this relation, you can have the EP is equal to SE into BE upon AB. Now we know that the EQ into EP, that is equal to EQ dash into EP dash. So by putting the values of EQ and EP over here, you are getting the new relation, and that relation is the EQ dash into EP dash, that is equal to BD into AE upon AB, SE into BE upon AB. By simplifying that relation, you can have the new relation like BD into SE, AE into BE, and upon AB square. So by converting this relation in terms of EP dash, you will have the BD into SE, AE into BE upon AB square into EQ dash. This is what about the link EP dash. Now join link BD and draw new link CF perpendicular to BD from the point C. So by doing so, you are getting that the geometrical relation between various links like BD is equal to BF plus FD, and SC is equal to BF minus FD. This geometrical relation you can get whenever you are joining the point BD and draw a circle CF or line CF perpendicular to BD from the point C. Now again, by putting the values of this, both of the values of BD and CE in this relation that we have derived, you are getting relation of EP dash is equal to AE into BE upon EQ dash into AB square bracket BF plus FD and BF minus FD. So by simplifying that, you can have the AE into BE upon EQ dash into AB square BF square minus FD square. But from the triangle, we know that the relation is the BF square is equal to BC square minus CF square, and of course FD square that is equal to CF square. So ultimately your relation will reduce in terms of EP dash, and that will be equal to AE into B upon EQ dash into AB square in bracket BC square minus CF square minus CD square minus CF square. Simplifying it, we have the AE into BE upon EQ dash into AB square multiply with BC square minus CD square. So over here, by carefully observing all that links that you have derived at the end of the relation of EP dash, all the links or the ratio are remain constant. So ultimately we can say that the dimensions of link EP dash is remain constant. Actually this distance represents the distance of the foot of the perpendicular from the point E, and that is remain constant. So it clearly means that the point P will always move in along a straight line, and which is perpendicular to a line ED. So this is actual Hart mechanism, and through which you can have the generation of a straight line that you require at the end. Now we are going to discuss a few more types of the special mechanism come under the category of approximate straight line generating mechanism. Look at this screen. First and most important types of special mechanism, that is Grasshopper's mechanism. Particularly in this mechanism, the slider of the Scott-Russell mechanism is herein replaced by turning pair. So ultimately entire mechanism will become Grasshopper's mechanism. Now in this mechanism, link AS is the turning pair, and which is perpendicular to link OS. Now the proportion dimension of such links will be designed in such a way that the dimension OQ upon Q dash should be always equal to dimensions of links QS upon QP. Now when link OQ and SO1 moves, the point P trace an approximate line. The two portions of the mechanism you can easily see and understand from the figure. So over here, whenever the mechanism getting rotates, of course point P will move from P1 to P or P1 to P2. So in that way you can have the straight line whenever you are rotating the link OQ. So this is the Grasshopper's mechanism we are using for the straight line generation of any profile. After that, there is a second kind of the mechanism, and that is Roberts mechanism. Generally Roberts mechanism contains 4 links AB, BC, CD and DL. Generally the rigid member, which is link QP, is rigidly attached to the link BC, and the dimension of various links are designed in such a way that the link BC should be always equal to 1/2 that of the link AD, and BP dash is always equal to the link P dash C dash. Now AB or link CD may be given the input motion. In that way the point P of the rigid rod QP will trace an approximate straight line that we require. So over here also we are getting the straight line by using Roberts mechanism. So dear student, in this lecture we have discussed some very special mechanism like Peace-Elliott mechanism. We have discussed upon Scott-Russell mechanism, Hart's mechanism also there, and at the end we have also discussed Grasshopper mechanism and Roberts mechanism. Due to limitation of time, I cannot have the very much depth analysis and derivation steps to be discussed with you at the end, because if I doing so it takes lots of time. So just kindly refer and revise the entire mechanism, its derivation and mathematical analysis. If you are finding any difficulty, let me know. We have the solution, and kindly stay tuned with us so that more numbers of such lectures we are uploading. Thank you very much.